Welcome to SanfordFlipMath. This is PreCalculus. We are working through the Demana, Waits, Foley, Kennedy PreCalculus book. We are in installment 2 of working with Trig Identities. First installment focused mainly on what the identities were, where they come from, and some thoughts about how to remember them. Just so we have this in this video at some point, just want to remind you this is what the identities are, and this is not exhaustive. This is just, you know, most of them, and there are rearrangements of these Pythagorean identities, like you can subtract sine squared from both sides, and etc. And my thought here was, for the most part, you kind of have the reciprocal identities. This one's not a big deal. This is a huge deal, and there are lots of rearrangements of this. You can divide both sides by cosine squared, and it becomes this one. If you divide this one by sine squared, it becomes this one. And this has to do, again, with odd and even symmetries. And again, cofunctions are equal for complements. That's complementary angles, or angles that add up to 90. And then the other two we will deal with. This is 5,3, and this is 5,4. And that's all I'm going to say about that. At this point, you need to just remember them. And I know this is not going to be fun, but it is what it is. And I will tell you that if you don't remember them, there will be lots of frustration. Okay. We're going to focus today on two ideas. One is simplifying trig functions, equations. And we did a couple of examples of that yesterday, and yesterday in the last video. And I just want to kind of focus on some specific techniques that are going to happen here. One, if you're not sure what to do, one recommendation is go to sines and cosines. So every single trig function can be written as either something about sine or something about cosine, or a combination. So like tangent sine over cosine, cosecant's 1 over sine, etc. So there are lots and lots of ways to, you know, rearrange things, but I would start there if you're not sure what to do. Okay, so that's one thing. Now you're not always going to want to do that. Okay, next, if you see stuff that's squared in there, maybe that's a time for a Pythagorean identity. So like sine squared plus cosine squared equals 1, etc. If you have fractions involved with addition or subtraction, maybe a common denominator is good. Sometimes conjugates come into play, because when you multiply by conjugates, you end up with difference of two squares. And if you have a complex fraction, then you want to clean that up, and the most efficient way to do that is multiplying by a common denominator in the top and the bottom. All right, that being said, let's start doing some stuff. Okay, this particular one, cotangent times tangent, well, there are a couple of different approaches, and again, keep in mind the goal. When you're trying to simplify, you're trying to make as clean, as simple as possible. I'd much rather write sine of x than a bunch of stuff, or I'd much rather write 0 or 1 or, you know, cosecant or something like that than a bunch of trig stuff. So for instance, this particular one, well, cotangent is cosine over sine. Tangent is sine over cosine. So what I just did was I made everything into sines and cosines. And then, nice thing about this is, well, cosine would divide out, sine would divide out, so all I'm left with is 1. Now, I know some of you are sitting there going, wait a minute, it was easier than that. Cotangent is the reciprocal of tangent times tangent. Well, those divide out. Okay, so which method was the right method? Well, obviously either one of them, because they both work great. So the answer to this, the simplified expression for this, is just 1. Okay, so you can go to sines and cosines. If you see a different way, you're certainly welcome to do that. And with many of these, and this can be the frustration, many of these there's more than one approach. Okay. Oh my goodness, look at that. That just looks terrible. All right, so let's talk possibilities. Okay, so if you have no clue what to do, then you can go to sines and cosines. Okay, so for instance, this would be sine squared plus, now tangent is sine over cosine, so tangent squared is sine squared over cosine squared. Well, that's kind of ugly. Now, before we get too far into this, I want you to notice that sine squared plus cosine squared is 1. Okay, so I can rewrite that as 1. Okay, so I still have sine squared over cosine squared. The entire thing. Now, you got to be really careful about fractions, and, I'm sorry, but fractions happen. Okay? Now, this is a complex fraction. So this is a fraction that contains a fraction. Well, there's more than one way to approach this, but what I'm going to recommend is multiplying by a common denominator. Well, a common denominator has to have all of the factors of all of the denominators. So this has cosine in it. This has cosine times cosine. So what I'm going to do is I'm going to multiply the top and bottom by cosine squared. So when I do that, I end up with, oops, sorry, I'm writing, it's just scrolling. Okay, so cosine squared times 1 is cosine squared times sine squared over cosine squared divided out. On the bottom, well, I have a cosine that divides out, leaving just cosine. I'm almost done. Cosine squared plus sine squared is the same thing as sine squared plus cosine squared. Secant x. Okay? Now, I want to back up. Excuse me. So the answer to this was secant squared. And just a quick recap. I went to sines and cosines. That sine squared plus cosine squared was 1. And then sine squared plus, I multiplied the top and bottom by a common denominator. And then I simplified the sine squared plus cosine squared again as 1. And then that's secant. Okay, now some of you back here at the very beginning maybe would have noticed this. So this really is 1 plus tangent squared, okay, over secant. Now, so here's the thought. If you see something squared, look for a way to use a Pythagorean identity. Well, I did that once, but this is a Pythagorean identity also. 1 plus tangent squared. Now, tangent squared has cosine on the bottom, so this is probably equal to secant squared. Now, let me just kind of pop back. There it is. Okay. So here it is. 1 plus tangent squared is secant squared. One more. There it is. So that means this numerator is secant squared over secant equals just secant. Okay, now, so quick little note to self. What did we get last time? Secant. What did we get this time? Secant. So here's a thought. The more trig identities you know, the easier your life's going to be. Okay, now, can you do it knowing just sine squared plus cosine squared equals 1? Yep. Would it have been nice to know 1 plus tangent squared equals secant squared? Yep. All right, let's do another one. Okay, so two fractions added together. Well, the recommendation here is get a common denominator. These particular common denominators also happen to be conjugates. So we got two things going on here. Okay, so to add two fractions, you need a common denominator. A common denominator has to have all of the factors of both denominators. Now, you can't just multiply the bottom of a fraction by something. You got to do the top and bottom to maintain its equivalence. Okay, so I'm multiplying each of these by the other denominator, which again happens to be their conjugates. So on the bottom here, the new denominator is going to be 1 times 1 is 1. Outer is negative sign. Inner is positive sign. And minus sine squared. In the numerator, well, 1 times that plus 1 times the other one. Okay, so all of this is equal to that. Does that look better or not? Well, some things to note here. Negative sign, positive sign. This comes up a lot, especially when dealing with conjugates. So this denominator is 1 minus sine squared. In the numerator, the signs go away. 1 plus 1 is 2. Okay, please remember that 1 plus 1 is 2. I know some of you are giggling, but I'm telling you, people forget that stuff. You make such big steps, and then the little stuff sometimes gets lost in it. Okay. Now, the other recommendation, one of the other recommendations is when you see squared stuff, think about Pythagorean identities. Okay. Well, just a reminder that sine squared plus cosine squared equals 1. Well, if that's true, and I subtract sine squared from both sides, cosine squared equals 1 minus sine squared. Well, this is 1 minus sine squared. So this is really 2 over cosine squared, also known as 2 times 1 over cosine squared. And again, I don't usually write that step, but I want you to see that 1 over cosine is secant. So this is 2 secant squared. And that's done. I don't know of an easier way to do this one. Sometimes I'll do something a hard way and then come back and go, see, you could, if you would have thought of this, then, well, this is it. I mean, this is what it is. So you see two fractions that you're adding or subtracting, you're probably going to be looking for a common denominator. Okay. And again, this common denominator happened to be from conjugates, so it ended up difference of two squares, which was something we could do Pythagorean identity with. All right, well, this is the other thing that we need to do today, and that's solving. And we have done a lot of equations where, you know, like we have like sine of x equals square root of 2 over 2, something like that, and we're going to solve between 0 and 2 pi, something like that. Okay, well, same idea. The only difference is that at this point we need to jazz it up a little bit. Okay, and I'm going to tell you that we're going to solve between 0 and 2 pi. That's usually part of the problem that's given, and I just forgot to type it in advance. Okay. All right, so first order of business, which is not really going to be much of an issue today, is all of your trig functions really need to have the same angle involved. So in other words, this is about x, this is about x, this is about x. Later on in the chapter, we're going to see this come up where some of those might be 2x and others might just be x, or some of them might be 4x. And if that's the case, they need to match, and there will be identities that you can use to straighten out that problem. Okay, so at this point, I'm just keeping it in there to be complete. Okay, okay. Can we factor it? Well, worth noting that we have a tangent in common. So let's try factoring that out. We're going to undistribute. Okay, we're going to factor out tangent, and what's left is square root of 2 times cosine, and then what times what do you multiply tangent by to get tangent? Well, just 1. Okay, and so just like when we do quadratic equations, when we're factoring and stuff, now we're just going to take each factor, set it equal to 0, and solve. So this is based on the fact that this is equal to 0. So if these two things multiplied give you 0, then one of those factors had to be 0. So either that was 0 or this was 0. It's the only way you can get a multiplication to be 0. Well, tangent is equal to 0. Now tangent, remember, is like slope on the unit circle, or y over x. That happens at 0 degrees, at 180 degrees, at 360 degrees, at whatever 360 plus 180 is. So solutions will be 0, pi, 2 pi. Well, I'm not supposed to include 2 pi, so that's out. Okay, so those two are the solutions for tangent. Now, if you recall, when we were doing this back in excuse me, in chapter 4, usually if we were going all the way around the unit circle, or all the way around from 0 to 360 or 0 to 2 pi, there were usually two solutions. Well, that's going to be the case again. It's just usually there are two solutions for each factor. So this factor has two solutions. This factor probably has two solutions also. Okay, so let's add 1 to both sides. Going to divide by the square root of 2. Now, we're not stopping here, so we really don't need to simplify this, but I know most of you are going to be a little more comfortable in recognizing that this is the same thing as the square root of 2 over 2. So cosine, square root of 2 over 2, where does that happen? Well, it happens in the first and fourth quadrants. Okay, cosine's positive in the first and fourth quadrants. And you probably recognize that the reference angle for this ought to be a 45-degree angle. So we're talking about 45, and then what do you do to get here? Well, if you go all the way around, that's 360, and then you got to back up 45. So this is 315. Well, that's pi over 4. And this is actually 7 45s. Now you can count them. You can just say 1, 2, 3, 4, 5, 6, 7 45s. So that's 7 pi over 4. Okay, so how many solutions do we have for this equation altogether? We really have 4, 2 from each factor. So 0 and pi over 4, and 7 pi over 4. Okay, and x can't be all of those things at the same time, so we've got a big fat or in the middle of it all. Okay, so 4 solutions. Okay, sometimes it's easier if you do a little square rooting. Okay, so for instance, I'm going to get this squared by itself first. You could play around with trying to factor this, but since there's no number in the middle and there's no second term, if you got everything on one side, well, all right, let's roll with that just for a second. If I do 2 sine squared minus 1 equals 0, then the question is, how would I factor this? And it's not real straightforward. Okay, so we're not going to do that here. All right, so instead, I'm going to divide both sides by 2. So I have the squared by itself. And then let's take a little square root on both sides. Now, just a reminder that if you're going to take the square root on both sides, then technically what's supposed to happen here is there's an absolute value of sine squared x equals the square root of 1/2. I'm sorry, absolute value is just sine. All right, one more time. Because it had a variable involved, not sine of the absolute value. And we never leave it like that. So this is going to equal positive or negative the square root of 1/2. Now, again, this is in disguise. I can do the square root of the top and bottom separately. Square root of 1 is 1. Square root of 2 is square root of 2. Yeah, that's exciting. Okay, and yet again, sorry about all of the 45-degree reference angles here, but it's just luck of the draw. Okay, so now the issue is, where is sine positive? Well, sine's positive in the first and second quadrants. And where is sine negative? Well, it's in the third and fourth quadrants. The sine of what reference angle gives me square root of 2 over 2, 45 degrees. So really, this ends up being in all 4 quadrants, much like we did last chapter, only instead of 2 quadrants, it's all 4. So I got 45 degrees, 135 degrees, 225 degrees, and 315 degrees. Now, any of these problems could come up where you're doing calculator problems. It's just these two happen to be problems that we could do straight off of the unit circle and do them exactly. Okay, so again, because of the positive or negative, it's like having 2 different equations to work with, and so we end up with 4 solutions total. Okay, so kind of like when you have x squared, expect 2 solutions, only if you're talking about all the way around the unit circle, and again, I know I forgot to put the 0 to 2 pi on here, sorry about that, this is a real common set of angles to work with. Okay, so plan on going all the way around unless it, just follow whatever it says. Okay, so where we're at right now, we didn't do a lot with identities in those last 2 problems, but there will be problems that identities end up happening. Okay, so we're going to leave it at that for this video. Continue to memorize those identities. Focus on the main Pythagorean identity, sine squared plus cosine squared equals 1. Learn some of the basic rules for the other ones. There we go. Okay, so spend a fair amount of time each day working on these, and remember, you can't use anything on the test. No notes, no cards, nothing. And the sad reality is, when you go to the next course and this comes up again, they'll be like, why would you need a note card? You remember that from PreCalculus. Yeah, sure you do. All right, on that joyous note, we're going to be done. And Sanford Flip Math, I guess that's it for now. Bye.